Look up at the night sky. On any clear evening, you are staring into the abyss of cosmic history, a vast and silent ocean dotted with familiar lights. You see the moon, our constant companion. You might spot Mars, a tiny red ember, or the brilliant beacon of Venus. You trace the constellations, patterns our ancestors drew to make sense of the infinite. For millennia, this celestial stage seemed predictable, a clockwork of planets and stars moving in familiar loops. We thought we knew the cast of characters. We were wrong. The universe, it turns out, has guest stars. Imagine looking through a powerful telescope, expecting to see just another faint icy rock from our own cosmic backyard, but finding something else entirely. A traveler from an unimaginable distance. A ghost passing through our solar system. This isn't just a thought experiment. It's exactly what happened. Astronomers diligently scanning the heavens stumbled upon a faint smudge of light that refused to play by the rules. This object was moving too fast, its path too strange. It wasn't bound by the sun's gravity in the same way our comets are. It was an outsider, a true alien in the most literal sense of the word. It came from the dark expanse between the stars. This discovery sends a shiver down your spine, the kind of thrill that reminds us how much we still have to learn. The familiar sky suddenly became a portal, a place where messages from other star systems could, and did, arrive unannounced. The moment of realization is pure scientific drama. You track the object's trajectory, running the numbers again and again. The math doesn't lie. The path is a hyperbola, an open-ended curve that screams, "I'm not from around here." It's a one-way ticket through our solar system. Unlike Halley's Comet, which returns every 76 years, this visitor would never be seen again. It was a fleeting encounter, a brief handshake with a messenger from another star. This wasn't just another rock. It was a physical piece of another planetary system, delivered to our doorstep. It was a chance to study, up close, the building blocks of a world that formed around a completely different sun. This visitor forces us to confront a profound reality. Our solar system is not an isolated island. It's part of a vast, interconnected cosmic ocean. Things can and do cross the interstellar void. For centuries, we have looked out and wondered what other star systems are like. We've used powerful telescopes to guess at their properties from light years away. But now, the universe has sent us a sample. It's like a geologist who has only ever studied rocks from their own country, suddenly being handed a stone from another continent. The questions become immediate and electrifying. Where did it come from? What is it made of? And what can it tell us about the place it once called home? This ghostly visitor was given a name, 3I Atlas. The I in its designation stands for Interstellar, a formal acknowledgement of its extraordinary origin. It was first spotted by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, in Hawaii, a set of telescopes designed to find near-Earth objects. But this was no ordinary near-Earth object. The sheer speed of 3I Atlas was the first major clue. It was careening through our solar system at a blistering pace, far too fast to be gravitationally bound to our sun. Think of it like this. If you throw a ball up in the air, gravity will pull it back down. But if you could throw it with enough speed, escape velocity, it would fly off into space forever. This comet arrived with more than enough speed to escape our sun's pull, meaning it was never captured in the first place. Its journey was a cosmic slingshot. Ejected from its home star system millions of years ago, likely by the gravitational tug-of-war of giant planets, it wandered the cold, dark desert between the stars. It traveled in solitude for an unimaginable stretch of time, before chance brought it into our neighborhood. Its trajectory was a one-time flyby. It swooped in, looped around the sun, and was flung back out into the interstellar darkness, destined to continue its lonely voyage. This rarity is part of what makes it so important. We can't just send a probe to another star system. The distances are too vast. But with 3I Atlas, a piece of another star system came to us. Thankfully, there was never any risk of a collision. 3I Atlas kept a safe distance, its path taking it far from Earth's orbit. Its importance wasn't as a threat, but as an opportunity. Interstellar objects like this are incredibly rare finds. Before this, we had only confirmed two others, Oumuamua and 2I Borisov. Each one is a precious, fleeting chance to analyze the chemistry of another corner of the galaxy. It's a scientific windfall, a limited-time offer from the cosmos. Astronomers around the world scrambled to point every available telescope at it, trying to capture every photon of light before it disappeared forever. The clock was ticking. The discovery pipeline itself is a marvel of modern astronomy. Automated telescopes scan the sky every night, their software flagging anything that moves or changes. Human eyes then verify these alerts. To find an object like 3I Atlas is like finding a single, uniquely colored grain of sand on all the beaches of the world. It's a testament to our persistent search and our ever-improving technology. The universe is vast and mostly empty, but it's not static, and our ability to spot these fleeting visitors is opening a brand new field of science: interstellar archaeology. We are sifting through the cosmos, looking for relics from distant unknown worlds. So what do you do when a piece of another star system flies by? You study its chemistry. As 3I Atlas got closer to our sun, the ice on its surface began to vaporize, creating a glowing atmosphere, or coma. By analyzing the light from this coma, scientists can determine exactly what it's made of. It's a technique called spectroscopy, and it's like reading a chemical barcode. The expectation was straightforward. Comets in our own solar system are famously dirty snowballs, rich in water ice. We assumed an interstellar comet would be much the same, since water is common in the universe. We expected to see a familiar recipe, but 3I Atlas had a surprise for us. A big one. When astronomers read its chemical barcode, they were stunned. There was very little water. Instead, the comet was spewing out enormous quantities of carbon dioxide, frozen CO2 or dry ice. It wasn't just a little bit of CO2, it was the dominant ingredient. The comet seemed to be made almost entirely of it. This was bizarre. In our solar system, comets are defined by their water content. Finding one made of carbon dioxide is like exploring a new continent and discovering that the trees are made of crystal, and the rivers flow with mercury. It was fundamentally different. This wasn't just a minor chemical quirk, it was a profound clue about the comet's birthplace. The type of ice that forms in a young star system depends heavily on temperature. Water ice can form relatively close to a young star, in the warmer regions of a protoplanetary disk. Carbon dioxide, however, needs much colder conditions to freeze into a solid. For CO2 to be the primary ingredient of a comet, it must have formed in an extremely frigid environment, much farther out from its parent star than where our own comets are thought to have originated. This single chemical signature told us a story about its home. The discovery challenged our assumptions about what is normal. We base our understanding of comets on the thousands we've seen in our own backyard. But our solar system might not be the standard model. The fact that 3I Atlas was so rich in carbon dioxide suggests that its home system might have had a very different structure or temperature profile. Perhaps its star was cooler. Or perhaps the comet formed in the extreme outer reaches of its system. A frigid realm we can only imagine. This alien comet wasn't just a rock. It was a messenger carrying a note that said, "Not all solar systems are like yours." How do we process a discovery this strange? Theoretical physicist Michio Kaku offers a powerful and elegant metaphor. He describes 3I Atlas not as a comet, but as a postcard from another star system. This isn't just a poetic turn of phrase, it's actually a scientifically accurate way to think about it. Like a postcard, it's a small snapshot from a distant place. It can't tell you the whole story of its origin, but it gives you a tantalizing glimpse. It carries a message, written not in ink but in chemistry. And the message of 3I Atlas is that the universe is far more diverse than we ever imagined. Kaku emphasizes that we are in the early days of receiving this cosmic mail. For centuries, all our postcards came from our local neighborhood, the planets, moons, and comets of our solar system. We started to think the whole world looked like our town. Now we're finally receiving mail from other countries, and we're discovering they have different languages, different customs, and different environments. The high carbon dioxide content of 3I Atlas is like a postcard written in a completely alien script. It tells us that the building blocks of planets, the planetesimals, can form in ways we hadn't fully considered. This perspective really shifts the focus from the object itself to what it represents. 3I Atlas is a data point, but it's a revolutionary one. It hints at the existence of star systems with vast, ultra-cold outer regions where carbon dioxide is the dominant ice. This could mean that planets in such systems form differently. Perhaps they have different atmospheres, different geologies. As Kaku would argue, each interstellar object we find is a piece of a giant puzzle. With just a few pieces, the picture is blurry. But as we find more, and we will, the image of our galactic neighborhood will become clearer and likely much weirder. This postcard model also carries a sense of wonder and urgency. You don't just leave a postcard from a faraway land sitting on the table. You read it. You study the picture. You think about the place it came from. Kaku's point is that we must do the same with these interstellar visitors. We must analyze every bit of data before they vanish back into the void. Each one provides a ground truth, a physical sample that tests our theories about star and planet formation. They force us to refine our models and expand our imagination. The universe is sending us clues, and it's our job to decipher them. The discovery of 3I Atlas, along with its predecessors Oumuamua and 2I Borisov, has opened a new frontier in astronomy. It's not just about finding another rock in space, it's about understanding the grand cosmic ecosystem. These objects are the seeds of planets, flung from their stellar nurseries. By studying them, we learn about the diversity of those nurseries across the galaxy. Before these discoveries, our theories about planet formation were based on one data point: our solar system. It's like trying to understand all of humanity by studying just one person. Now, we're finally getting to meet the neighbors. Each interstellar object is a unique science experiment. Oumuamua was strange for its shape and movement. 2I Borisov looked more like one of our own comets, suggesting some systems might be similar to ours. And 3I Atlas showed up with its bizarre carbon dioxide-heavy composition. Together they paint a picture of incredible variety. It seems there is no single correct way to build a solar system. The galaxy is a grand laboratory, running countless experiments in parallel. Some systems might be rich in water, others in carbon dioxide, and others perhaps in chemicals we have yet to even consider as primary building blocks. This has profound implications for the search for life. The conditions for life as we know it depend on liquid water. If many star systems are built from water-poor carbon dioxide-rich materials, does that make life less likely? Or does it mean that life might find a way to arise in completely different chemical environments? These are the questions that keep astrobiologists up at night. Interstellar objects provide our first real tangible clues. They are messengers from the habitable or uninhabitable zones of other stars. They are telling us about the raw materials available for building new worlds. Furthermore, these objects help us understand our own history. Our solar system was not born in isolation. It formed within a cluster of other stars. In its chaotic youth, our system likely ejected its own comets into interstellar space and was visited by others. It's possible that some of the water on Earth was delivered by comets, and some of those comets might have been interstellar visitors themselves. We might be, in a small but real way, composed of materials from other stars. By studying objects like 3I Atlas, we are not just looking out at the galaxy, we are looking back into our own deepest origins. The story of 3I Atlas is more than a celestial event. It is a lesson in humility and curiosity. For so long we have looked at the cosmos through the lens of our own experience, assuming our solar system was a blueprint for all others. This interstellar postcard, written in the ink of carbon dioxide, tells us to think bigger. It reminds us that the universe has no obligation to conform to our expectations. Its complexity and variety will always outstrip our imagination. The cosmos is not just stranger than we imagine, it is stranger than we can imagine. And that is a wonderful thing. This is a call to action for the curious mind. Every new discovery, whether it's a bizarre comet, a new exoplanet, or a ripple in space-time, is a message. The universe is constantly revealing new pages of its story. Our job is to learn how to read them. This requires us to stay curious, to ask questions, and to embrace the unknown. When a discovery like 3I Atlas shatters our old models, we shouldn't be disappointed. We should be thrilled. It means there is something new to learn, a deeper mystery to explore. The journey of science is not about finding all the answers, but about discovering better and more profound questions. Think about the future. With new observatories like the Vera C. Rubin Observatory coming online, we are poised to discover not just 1 or 2 interstellar objects per year, but dozens. We are about to receive a flood of cosmic mail. Each new visitor will add another piece to the puzzle of our galaxy. We will begin to map the chemical diversity of our stellar neighborhood, to understand the different ways planetary systems can be born. We are standing at the dawn of a new era of exploration, one where we don't have to go to the stars because the stars are coming to us. So the next time you look up at the night sky, remember that it's not a static, predictable backdrop. It is a dynamic, living space full of travelers on epic journeys. Remember that the universe is constantly sending us messages, challenging our assumptions, and inviting us to expand our perspective. We are a part of this grand cosmic conversation. Let's keep our eyes open, our minds curious, and our telescopes pointed at the sky. The universe is speaking, and it's telling us that the most exciting discoveries are still ahead. Let's be ready to listen.